Hello everyone, I'm Goody K3NG. I receive a lot of questions about various Arduino projects and memory, mainly from folks trying to fit certain projects, certain feature sets on Unos and Nanos. I'm going to explain a little bit what to look for when you compile and how Arduino memory works. Here's a compilation of my Arduino CW Keyer project, and the lines that you need to look at are right here. You may not be familiar with this development environment. This is Microsoft Visual Studio Code. You get the exact same compile message here if you're using the Arduino IDE. So you'll always get this message here. It says how many bytes were used for program space, what the maximum is on the chip, and then there's this global variables of dynamic memory and local variables. And this is the one that usually is the problem, not the program storage space. Let's talk a little bit about how Arduino memory is structured. I'm going to talk about the two main AVR Atmel chips that are used, the ATmega 328, this is what you find in Unos and Nanos and other variants, and the ATmega 2560, which is in the Mega. There's three segments of memory. Flash, this is what your program goes into. SRAM, this is where your variables go, both global and local variables. And then there is EEPROM. This is where configuration is stored. This is non-volatile memory. When the unit's powered down and powered back up, all of the contents will still be in EEPROM. That is not erased. The Mega ATmega 2560 has the same structure, except as you can see it's larger. It has a lot more program space, more SRAM, and EEPROM is bigger as well. With both of these, with the Arduino code, the bootloader actually uses a portion of the memory. For the ATmega 328, it uses a half K, and for the ATmega 2560 running on the Mega, the bootloader uses 8K. So, like I said earlier, the program is what goes into Flash, the main code. The variables, which are changing as the code runs, is what goes into SRAM. A chunk of the variables are used for global variables. They exist all the time, so they're always taking up memory. As functions are called in the code, local variables are created in the SRAM, they're wiped out, and new ones are created as another function is executed and exits, they're wiped out as well. So your SRAM usage is going to vary at runtime. Going back to the compile message, this is what you need to look at right here is global variables, and I'm compiling for an ATmega or Mega 2560, the bigger chip. So dynamic memory is actually SRAM, and we're using only 13% of that, and that leaves about 7K for local variables. So in this particular instance, we have a lot of space for local variables. Normally I don't get concerned unless we're getting below 1K or maybe 800 bytes. If you get a compilation message where you have 500 bytes left for local variables, it depends on the project and what you're doing and what features, but that's where you start to have problems. And if you run out of local variable space, there's no way for the Arduino to tell you that. It just manifests itself as weird things happening because it's out of variable space. Things will get overwritten. The behavior of the Arduino is going to become unpredictable. Your Arduino may crash, or you may just have unexplained problems. Here's another compilation of the K3NG Arduino CW Keyer project. This time I've compiled for the Arduino Uno, and here you can see the program space. We're very close to using all of it, 93%. I would not recommend going any higher than 94, 95% of an Uno or Nano with the program space. Here with global variables, we're actually in pretty good shape here. Global variables and local variables, we have 933 bytes left for local variables, so we would probably be okay in this particular instance. And here's a final example, compiling the keyer code again for the Arduino Uno, and I added an additional feature, and this is what it looks like when you've run out of program memory. Very obvious here, 131% of program storage space. That obviously is a bad thing, and it even gives a little link here to go to troubleshoot. but amazingly here we actually have still a good amount of space left for local variables, 868 bytes, but naturally this code's not going to fit on the device. So I hope this little video helps you out in troubleshooting memory issues or compiling your code. If you need more support, you can always go to the Radio Artisan group and Groups.io. 73.